Hey there, are you finished with your robot? Does it feel like a part of it is missing, as if there's lost potential? If so, you've come to the right place. I'm Victor Peel from Team 11475B, and allow me to teach you the applications of transmissions in VEX robotics. To start, let's figure out what a transmission is. In a broad sense, a transmission is any mechanism in which power is transferred from one output to another. Whether changing output torque or the mechanism being powered entirely, transmissions have many applications throughout a robot. First, you'll need a good support. Then, we will be using 4 high-strength 60-tooth gears connected together as our driver. We will connect these together to allow for a larger contact area for our sliding gears. Now, we need to line up the teeth so that the gears can slide properly. In order to do this, we put a screw connecting all 4 of those gears together, but we do not tighten it all the way. Next up, we will need to prepare the base to have the axle put into it. So for that, we will need to add a bearing on the opposite side of the motor. One important thing to note when using moving parts like this is you want a maximum and a minimum of 2 points of contact for any axle you are using. This reduces friction and helps prevent problems later on. In this case, the 2 points of contact will be the inside of the motor and the bearing. Now we will throw on a 4mm spacer, the gears, and then a shaft collar. Finally, we will tighten the screw going through the gears. We waited to do this because doing it after putting it on the axle helps with alignment. Then, on goes our next set of bearings. Again, we need to maintain 2 points of contact with the axle, so don't overdo it. Now I'll make a quick handle with a bearing, shaft collar, and a spacer. Put on all 3 gears one by one. Notice how they have rounded edges. This allows them to slide better and mesh with newer gears. To round these gears, you can either use a rotary tool or go at it with sandpaper. Then finish this part off with a rubber shaft collar and a 1/4-inch spacer. Then another set of bearings. Now we will build our output axle. We will be using the same 3 sizes of gears that we had before: 12-tooth, 36-tooth, and 60-tooth. Between each gear, you will want a 1/4-inch spacer and an 8mm spacer. You need these there because this prevents any 2 gears on the same axle being engaged with any 2 gears on the other axle. If that happens, the entire mechanism will stall out and it will not work. This final part is optional, and this is a wheel to see the speed change in your transmission when testing it. To change gear, all you need to do is push or pull on your handle. And now you're finished. Modify this transmission in any way you want to fit any use case your robot needs. You can adapt the concept seen in a manual transmission to make a smaller 2-speed automatic transmission such as this one. You can easily use the linear motion of pneumatic cylinders to switch gears. To prevent damage to the system, you will want to run through a pressure regulator to decrease the pressure to between 10 to 20 psi. This can also be easily adapted into the drivetrain. Rather than changing output, speed, and torque, a power turn-on transmission changes which mechanism is being powered entirely. This small modification to the previous transmissions can allow for nearly unlimited potential in your robot. Overall, transmissions are a great way to push your robot past its limits and achieve the next level of creativity.